All right, guys. So today I would like to talk about higher order functions, which is a very important principle in JavaScript. We will talk about higher order functions a few times until the end of the bootcamp, particularly when referring to asynchronous JavaScript. I think on the next week, I'm pretty sure that's on the next week, we have a couple of workshops to deal with asynchronous JavaScript and see how can we handle multiple processes running in parallel. All right, so let me present you a problem. If I have a function called sum, and function sum has a and b, um, obviously I can add multiple values by just returning a plus b. So then I can do console.log sum. So for instance, 5 and 6, and that's gonna return 11, right? Let's just a fake test just to make sure everything is okay. Here you go. All right, but now what happened, guys? What happened if a is not a number? Yeah, a is a number, b is a number. Of course, a could be something different, right? So if we're building another function, so you can pass whatever you want here, right? So you can pass a string, or you can pass an object, or you can pass an array, or you can pass a boolean. Functions, can receive many types of arguments. So these ones are expected, right? Strings, booleans, objects, arrays, numbers, of course, right? But let me show you something different. Can we do that? Can we pass a function as an argument? Of course we can. Of course we can. Fn, or you can call it Brexit, I don't care, yeah? So that argument is the function. So how can we get the hello message displayed at the bottom of my screen, guys? That's correct. Yeah. So fn is a function. Fantastic. Let's call the function. Yeah. So that's what we are doing here. We're calling the function, and then you see that the result of calling the function is returned eventually. Yeah. So what is that gonna display, guys? Number 6. That's correct. And look at the next question, guys. I want to display 11. Can anyone tell me what else should I change in my code? Okay, but I don't want to hard code 5. I want to add 6 plus 5. That's what I want to do. Here? That's correct. That's brilliant. Elena, that's brilliant. Wait to see how many points Elena got this week, because she's been solving the unit test challenge. All right, so look, that's going to return 11. Why? Well, fn is a function, right? Look, I'm now highlighting the fn function. So because it's a function, we can call it. And because we can call a function, that means that we can pass arguments, right? So look, I can pass number 5, so n will be 5. So then the result of calling that function will be 6 plus n, in other words, 6 plus 5, which is 11. So if you build that, then foo becomes what we call, foo is a HOF, higher order function, okay? Which is a special type of function that receives an argument, which is another function. Any questions? No? All right, so then back to the sum example. Look, you are gonna tell me what to do. So I want to return a, oops, not argument, sorry, a plus b. Not plus b, what the hell is that? A plus b. All right, so can anyone tell me what should I do? I want that function to return 7, for instance. That's controversial. That's not gonna work, Max, because what are we doing here? I mean, we're displaying number 4 and number 3. Yeah, yes. I want actually to call. I want to call the function, and I want to, yeah, sum. Yeah, okay. That's crystal clear, right? We need to call the function first, and then that's the complex part. What else do we need to do? A plus B, A parentheses, N plus B, A parentheses, no. I'm following your instructions, Vicky. N outside, yeah, plus B, N and M. All right, guys, I'm lost, but that's not correct, Vicky. Wait, Vicky. That's far away from being correct, right? So I don't think there is any point of continuing with that approach, because that's clearly wrong. That's clearly wrong. All right. Before presenting you the answer, I would like to hear from anybody else who wants to participate. Does anyone has any idea about how to solve the problem? So far we know that, right? We've had to call the function. I mean, some code may be missing here as well. I didn't say that code lines 1 to 3 is perfect. I just want to, complete the exercise. Maybe it is a bit better if I complete the first line, yeah? So sum receives 2 arguments, A and B. And then we want to run some operations with these arguments. So in other words, here, guys, we need 2 arguments. We need something here and something there. 2 functions. How do we do that, Elena? That's interesting, Elena. That's interesting. Look, sum receives 2 arguments. Look, that's the first argument, A. That's the second argument, B. You see, guys, A, what type of data A is? It is a function, right? Of course it's a function. Because it's a function, can we call it? Of course we can, right? Yeah, of course we can. And same thing with B. What type of data B is? It's a function, correct. Can we call it? Of course we can, right? So what's the result of calling the function A? Correct, 3. And what's the result of calling the function B? 4, correct. So that's essentially the result of adding 3 plus 4, which is obviously 7. Yeah? So that's correct, Elena. You see, I know that's a bit complicated, but if you break the example down, it is not that difficult. Yeah. Remember, any function can receive any type of argument, not just strings, booleans, classic, numbers, arrays, objects, the classics, but also functions. We will see next week why this is so convenient. When do you really need, or when is it a convenient practice, a convenient thing to do that? Yeah. But before presenting you a realistic example, I need you to have a basic understanding about how to deal with the problem before presenting which problem does it try to solve. Any questions? No? So once again, this is a higher sum is a h of f, higher order function, because it receives a function, actually 2 functions. It receives function as arguments. Yep, we got 2 functions as arguments. Yeah. of course, we could combine that. So, for instance, the first argument could be, actually, let me try to do something. I want you guys to tell me what else do I need to do to get 7 again. There is something wrong somewhere. The algorithm should return 7, but it's not working. Can anyone tell me what should I do? Yeah, that's correct, Vicky. Yeah, we put 4 in the second. You see? So the way it works is the first argument, it's a function. Here is a function. However, the second argument is just a number. Fantastic. So we call the function a, it returns 3, and then we add 3 plus 4, which is 7. So if we run it, yeah. So definitely when talking about arguments, we can combine, we can make it super complicated, arrays, object, you know, we can spend hours dealing with a monster, yeah. But you know that's pretty much the idea behind it. You got a function that is passed as an argument. So sum is a higher order function because it receives functions as argument. However, when talking about higher order functions, there is a second use case scenario. Let me present you the second use case scenario. Look, I'm gonna create, I'm gonna call sum, and I'm gonna pass 3 and 4. Ignore the function sum. So I create a function sum, I call it, I say, not so sum, what the hell is that? Sum, 3 plus 4, right? And then look. You see, now the result is going to be a function. So I can call the function as well. And I need your help. I need your help because I want that function, I want that console log to print 12. So let me prepare the function for you, function sum, and we got a and b. And now I need your help. Can anyone tell me what should I write on line number 3 to satisfy that problem? Obviously, don't tell me return 12. Right? I want that to be dynamic. So I want to add 3, 4, and 5. How can we do that? That's very interesting, Lauren. Indeed, you are absolutely right. So you see, it returns 12. Why it returns 12? Because in this occasion, guys, can anyone tell me what type of data, apart from Lauren, what type of data sum returns? Be careful, Maxime. Be careful. It doesn't return a number. It returns a function. Yeah? It returns a function. So result is not a number, it's not a Boolean, it's not a string, it is a function. And because it's a function, can we call it? Of course, we can call it, right? We can call it. So once we call it, passing a number, represented by the letter C, as Elena suggested, Lauren suggested, we can rename it, of course, yeah, but it's so natural, right? We got A, B, and let's call it C, right? So once we call the function, then pop, we execute that operation. Yeah. So in this occasion, sum also is a higher order function, but not because it receives functions as arguments, but because it returns a function. You see the two types of higher order functions. A function that receives another function as argument, as we've seen before, or in this occasion, sum is a higher order function because it returns another function that we can obviously invoke. Any questions? Yep. It is the same. It is the same, Maxim. So when you have a callback, and we'll see that next week again when talking about asynchronous JavaScript. So a callback is essentially a function that gets passed as an argument. Yeah, and that converts whatever that argument is, whatever that function is, I'll convert it into a higher order function. So yes, that's correct. That's correct. A callback is an argument which is a function, indeed. Any other questions, guys? Yeah. So you, that's interesting. That's interesting. Wait. That's very interesting, Lauren. Look, result, it's a function. So what we are doing here is we are saving a reference to the function. We are saving a reference to the highlighted code into that variable called result. And then later on, could be 1 line later, could be 2 minutes later, 1 hour later, who cares? Eventually, we call that function. 2 steps. We save a reference, we save a pointer to the method, to the function, and then we call it. However, what Lauren is suggesting is that we can do something like that. And that is correct. That is correct. That's the same code. It's actually the same process. We call the function because that function returns another function. Then we call it straight away. You see? So, what type of data, guys, result is? Are you sure? It was a function until here, Maxime. It was a function. But then look at what we have on the right-hand side of that expression. It was a function, but we call the function. So what is that inner function returning? What type of data is it returning? A number. That's correct, Maxime. That's correct. That's correct. So result. Now result is in this case a number because instead of assigning the function and then calling the function, we did everything in one go. You see? So you got everything in here. Yeah. Can we guys? Well, I'll tell you something. I'm gonna make it more complicated. Look, now I'm passing number 6. I want you to tell me what the hell I need to do in order to get number 18. Like that? Lauren is absolutely right. You see? We can nest, we can have a function that returns another function that returns another function. Yeah, so that can get definitely very tricky. Yes, I could spend hours here dealing with multiple levels of nesting. But that's the idea, yeah? So sum returns a function. When we call that function, look at the highlighted code, then that's another function. So when we call the other function, then we add all the numbers that we've been passing previously. Questions? Guys, what type of data sum returns? It's a function. Sum returns that piece of code. Guys, are you following when I highlight the code? Because that's not trivial. I'm highlighting, important stuff, yeah? So when I call sum 3 and 4, that returns everything, which is a function. Yeah, I'll do that. I'll do that in a minute. Indeed. Yeah, indeed, Max. I will refactor the code in a minute following classic functions to see if it becomes more readable. Yeah. So let me go back again. So we got function sum, and that's everything. Yeah. And then because that is a function, we can call it. Yeah. So when I call with the number 5, I'm essentially here. And what type of data that is, guys? The highlighted code. It is no, it's not a number, Maxime. That's a function. You see the arrow function? That's another function. Because that's another function, I can call it again. So if I call it again, then I'm here. Exactly. Eventually, you're right, Maxime. Eventually, we return a number. Let's do what Max suggested. So Max suggested to refactor the code using classic functions. So refactoring the code using a classic functions, that will look something like that. That's literally the same code. I'm not sure if that's less readable, more readable, but that's equivalent, yeah? So what we, okay, then great. You see, you get a function, sum, that returns another function. And when you call that function, it returns another function. You see? So let me do something. Breakpoints. Long time, no see you. So can anyone tell me? All right, we got 4 breakpoints. So can anyone tell me what's going to be the execution order? Maxim, of course you can try. Okay, thank you, Maxim. We'll see in a minute if you're right or not. Anyone else? All right, thank you, Vicky. Anyone else? All right, when all the girls agree on something, it's hard to retaliate, right? So indeed, they are right. Maxim, I don't know why you thought that the code is going to stop on line number 11 4 times. That's not correct. We call the function just once. Yeah? So that's why line number 11 will run only once. Do you see any loop, any for each, any map? Do you see any looping structure? Not at all. Yeah, not at all. Yeah. All right. Okay, fair enough. Let's do something. Let's refactor the code a bit. Look, result 1 equals sum 3 and 4. Let result 2 equals result 1, 5. Let result 3 equals result 2, 6. Can anyone tell me what type of data result 3 is? That's correct. That should be the number. Let's see if it works. And then I'm gonna, here you go, you got the number. Let's add some breakpoints again. So look at how many breakpoints we got tonight. Yeah, today, not tonight. So you got 7 breakpoints. So now I'm gonna ask who wants to get some extra points on the board challenge of the week. Yeah, of course. All right, thank you, Vicky. Who else? All right. Thank you, Elena. Are you missing some numbers? I don't know. Anyone else? Max, Lauren? Okay. All right. All right. I'm sorry, guys, but Elena is right. Why is she right? So first of all, guys. I mean, if you were part, guys. Sorry, Vicky. I need to speak now. So I could accept you to struggle here, right? That's fine. But a company will never accept you failing here in that part. So why line number 14 will run first? That doesn't make any sense. Again, ignore the function. Even if the function does hello world, right? Let's focus on that bit. We follow a chronological order, guys. We read this algorithm top to bottom. So I don't know what's going on here, but for sure, it will be 11, 12, 13, and 14. And then these numbers may be in between. I don't know. But in this occasion, right, guys, we follow JavaScript sequentially, right? First line, then the second line, then the third line, and finally, eventually, the last line, yeah, which is line number 14. So we then need to combine that order 11, 12, 13, and 14 with the complex function. Yeah. So result one. That's going to be the first one. So we call the function. So we are here. Pop. That's it. So that's why after 11, we are going to stop on line number 4 because we are here. And we return the function. So result two will point to that function. All right, so we stop on line number 12, and then we call the function it returns. Here you go. So we are then gonna call the next function. And eventually, result 3 will refer to the last function here. Yeah, so we call it, so D will be 6, and eventually the result will be whatever that returns, A plus B plus C plus D. So let me run it. And then you see 11, and then 4, and then 12, and then 5, and then 13, and then 6, and then 14, and then that's it. The result will be printed. Yeah. So, yeah, any questions? You never see the breakpoints. Hello? Come on, we've done that 20 times, Vicky. You mean creating variables. I see what you mean. Okay, well, yeah. Yeah. Okay, fair enough. Let me show you something a bit different. So you got function sum. We've seen the two types of higher order functions. So let's try to build something simple to combine them. Look. So I'm gonna create the algorithm, and then you are gonna tell me how to deal with it. So if I ask you, please call that algorithm with the number, and it should return, for instance, I don't know, 7 maybe? Can anyone tell me how should I invoke that method? Yep. Mm-hmm. Mm-hmm. Okay, what do you think, guys? That's interesting, Lauren. That's very interesting indeed. Let's see why. Look, what type of data A is? How do you know it's a function? Correct, because we're calling it as a function, right? So A should be a function, returning something, a number, yeah, because we want to add some numbers. Fantastic. Number 2. What type of data B is? How do you know it's a number and not an array? Correct, because we are running some math operations further later on, right? So the second argument should be a number, for instance, 4. And then, what type of data sum returns? It's a function, that's correct. Sum returns, when I call sum, blah, you see, when I call it, it doesn't return a number, it doesn't return a Boolean, it returns a function. So I can call it, right? If it returns a function, I can call it. So which variable refers to one, A, B, or C? C, that's correct, yeah? It's variable C. So then eventually I can do A plus B plus C, remembering that A is a function, so I need to call it. Yeah. What happened? Let me ask you something. What happened? I'm thinking about the best way of solving the problem. You see the change I've done. Yeah. So A now receives an argument. What happens if I want to return 10? What should I change? Yep. 3. Why 3, Maxim? Yeah. But the thing is, Maxim, you're right. But I want you to be able to prove that you're right. Yeah. So yes. So if we pass 3 will be n. So the result of calling the function A will be running n, which is 3 plus 2, that returns 5. So that bit will be 5. So then the function will return 5 plus B, which is 4, plus C, which is exactly. And because of that, that's going to return 10. Yeah? What happens if I add breakpoints? 4, 5, and 11. 11, 4, and 5. Let's run it. First of all, we start calling functions, easy. And then, of course, yeah, we go to line number 4. We can inspect value B is going to be number 4. Here you go. If I inspect value A, that's a bit weird, but can you see, guys, it's a function? Can you spot that? Yeah, you see, it's a bit hard. So with B, it's a number, but you see exactly, look at the arrow function, as Maxim said, that's clearly a function, right? And then if we keep running on line number 5, B will remain 4, C will be 1, and then A, when we call it, I cannot actually, can I preview that? I don't think so. No, I can't. But anyway, yeah, so that returns 5, yeah? And eventually they will return 10. Any questions? So that's the two types, just to recap, the two types of higher order functions. A function, sum, is a higher order function if any of these two conditions are met. First of all, if the function receives an argument as a function. You got it here. Also, if the function returns another function. You got it here. Yeah. So in this occasion, sum is a higher order function because of these two reasons. Yeah. I'm gonna share the snippet with you, and let me tell you something, guys. I know that's complicated, However, if I were an employer, my goal wouldn't be you to understand what I have presented, because that's a bit advanced. Yeah, I have to admit that. However, it will happen. It will happen to you that you'll be called to join a job interview, and they will tell you, what the topic is about. Yeah. So, what's the message? They are not expecting you to know that topic up front, but of course, if they tell you the topic, if they tell you we're going to talk about higher order functions, it goes without saying you should prepare it. Yeah? You should prepare it. So the goal of the board challenges is to prepare them. And of course, guys, I've been doing that for many years. I can really see who is preparing these things and who is not. Yeah. I mean, that's a bootcamp. That's up to you, right? I know you got different priorities, but let me give you an advice. If you go to your interview and they tell you that they are going to talk about a particular topic, please prepare it. Yeah. We got 2 board challenges left, and they are anything but simple. So if you don't prepare them, you are going to be lost. So next week, we're going to talk about prototypal inheritance. The last week, we are going to talk about lexical dis. We always leave these 2 topics towards the end of the bootcamp because, first of all, they are complex, particularly lexical dis is a complex topic, but also because you may have to face related questions in a job interview. So I want to make sure that all these coding techniques, principles are fresh in your head. Yeah? So please prepare the remaining board challenges. Yeah, don't expect to understand these topics without any preparation, because unless you are a unique person, unless you have a natural ability for coding, which is clearly not my case, it's going to be impossible to understand these things in real time. So the reason why I keep referring about the same thing is I've seen many times many students thinking, oh, I don't have an ability for coding, and I feel behind. I don't understand things that feel obvious for my colleagues. But reality says that 99% of the time, someone who understands something is because he or she has prepared that up front. Yeah. So, I mean, look at Lauren. She's been preparing that, clearly. And that's a good thing. Yeah. I don't think Lauren is smarter than anyone else, but she's preparing things. Yeah. And that's an absolutely valuable asset. Yeah. Don't forget something. You're going to break into tech and you're going to know nothing compared to your colleagues. So they are not going to expect you from knowing all these things up front, but at least they want to see, they want to evaluate, they want to prove that you have the ability to learn. Yeah? And that's why these board challenges are so useful, because you have the chance to prepare something up front. Yeah? Anything else? Correct. No. So that's for the next week. So Maxim, next week the board challenge will be about prototypal inheritance. What that means? We'll play with some examples, and the last one will be about lexical dis. Yeah. So this is all about JavaScript techniques, JavaScript patterns, JavaScript. The way JavaScript works. Yeah. You got the snippet on Slack, so it goes without saying. That if I were you, I will go to the playground and I will just repeat the workshop. I will have breakpoints. Yeah. Yeah. It's on the Slack. Yeah, the one I just finished. It's on the Slack already, Maxim. That's all right. Yeah, this session is live. It's being recorded right now, Alaya. I'll send you the link. I'll send you guys the link in a minute in case you wanna rewatch it. Anything else, people? No. Remember, we got a workshop about asynchronous JavaScript callbacks. When is that running? I think it's on Monday. Asynchronous JavaScript with Column. I don't have the calendar with me, guys, right now, but definitely the workshop is happening, and I think that's on the next week. Not sure which day is that. So the thing is, if you prepare, if you revisit this session, it's gonna be much easier to understand the next one. Yeah? If you don't revisit this session, it's gonna be way more complicated. Yeah, and in that asynchronous JavaScript session, I would like to present some real life examples about when should we use higher order functions. Yeah? But that will be on the next week. Anything else? Are these questions about the workshop? Okay, then yeah, of course, then you can stay. Yeah, absolutely. Cool. Anything else, guys? No? Fantastic. Fantastic. Yeah, of course, if you got any questions, please let me know. That was it from my side. Thank you very much and see you later.